A chemical polarimeter is a device for measuring stereochemistry of molecules, and today I'm going to give you a brief introduction on how to use the polarimeter. First thing to note is that it has two cables coming out of it. One is an analog and one is a digital. They will only fit into specific ports on your interface. Today I'm using the LabQuest Mini with a computer and Logger Pro, but you can also use it with LabQuest. Now that I have everything plugged in, I'm going to open Logger Pro. You need to have Logger Pro 385 or newer for the polarimeter to work properly. Make sure you note the axes on the graph. The y-axis should be illumination and the x-axis should be angle. All of your data with the polarimeter is taken in reference to a blank. Today I'm working with sugar solutions, so my blank is water. I fill one of the sample cells to 10 centimeters with water. I don't always have to fill it all the way to 10 centimeters. The least amount I can get away with is 2 centimeters or about 5 milliliters. Place the sample into the polarimeter, snap it into place. And now, start data collection in Logger Pro. And after I've done that, I begin to rotate the analyzer, and a cosine squared waveform should appear on the screen. Data collection will continue for 15 seconds, or I can stop it early if I like. Once data collection is stopped, I need to make sure and store that run so I can compare my optically active sample to the water. Now I'm ready for my optically active sample, which is a 30% sucrose solution. I've also filled this one to 10 centimeters. Place it in the polarimeter, begin data collection, and rotate the analyzer. You can see right away qualitatively that the cosine squared waveform has been shifted to the right. Sucrose is therefore a right-handed molecule. If I had used a negative sugar like fructose, I would have gotten a shift to the left. This data can be analyzed quantitatively several different ways in Logger Pro. The quickest and simplest way to quantitatively analyze these results is to use the statistics feature. To do that, I select the first peak after angle 0 and tap on the statistics button. I want to analyze both the blank and the sample at the same time. Select OK. And so the value that I care about when I'm trying to figure out the optical rotation is the angle at maximum illumination, so the absolute peak here of this wave. Statistics gives you that value right here with the maximum y at x. So this is the value of the angle at maximum illumination. For the blank here, it's 145.5. And for the sample, it's 166.8. To get the optical rotation of my sample, I just take the difference between those two values, and then I can use that value for further analysis of my sample. To do a more accurate value of the optical rotation, you can do a Gaussian fit or a cosine squared fit. And I'm going to show you how to do that in the next video.